Hi, everyone. While I've been out, you were assigned to do this worksheet as homework. And looking over some of your worksheets, the work that you did, I realized that I really need to walk you through this. So I'm actually assigning this video as part of your homework to listen to the explanation for why the answers are what they are for these. Okay, I'm going to talk you through all of this. Why don't we get started with the first one, which is really simple. All right, a hot cup of coffee cools as it sits on a table. So the coffee is going to cool. That means it's going to lose energy. Let's just fill in this bar chart, okay? This is hot coffee, so I'm just going to go ahead and give it 4 bars of thermal energy. And it's liquid, so I'm going to give it 2 bars of phase energy, okay? We know that we're going to lose energy, okay, because, it's cooling down. All right, in the final part of the LOL chart, this thermal energy has decreased to room temperature, which is 2 bars. This is something that we've already established. This is how we're going to do this. And we're still dealing with a liquid, so it's just 2 bars. We went from, we lost 2 bars of energy in this process to the surroundings. Okay, so the hot coffee became cold coffee, and that's number 1. In number 2, we've got a can of cold soda. All right, so it's liquid soda. So why don't we just start with the phase energy? That's 2 bars for liquid. It stays liquid in the end, so I'm just going to put 2 bars. Okay? So as far as the phase has not changed, so the phase stays the same. We start with 2 bars of energy. We end with 2 bars of energy. All right, we've got cold soda. All right, well, since it's cold, it's below room temperature. And since room temperature is 2 bars of thermal energy, I'll put this as 1 bar of thermal energy. And this cold can of soda is going to warm up to room temperature. So in the end, we're going to end up with 2 bars. Why 2 bars? Because we've already established in a couple of videos ago where I said we're going to call room temperature 2 bars of thermal energy. Anything colder than room temperature is going to be either 1 bar or maybe a half a bar if it's really, really cold. If it's warm, maybe 70 degrees Celsius, that's pretty semi-hot, that could be 3 bars of thermal energy. 100 degrees Celsius, like the boiling point of water, would be 4 bars of energy. Okay, so that's where these bars of energy are coming from. All right, what are we gaining? See, we're bringing in Q energy, right? And we're just bringing in 1 block of energy. Okay, you can see that in the graph there. Okay, so in this last one, this is a little bit more complicated. We've got a phase change happening, and that makes a big deal, okay? In order to understand what's going on with this phase change, I'm going to draw a temperature time diagram. This is time, this is temperature, okay? And we're starting at 20 degrees Celsius, and we're going to freeze this water, and it's going to become minus 8 degrees Celsius. So in my graph, I'm going to call that 20 degrees Celsius. I'm going to call this 0 degrees. Actually, I shouldn't do that. I'm going to call this 0 degrees Celsius. Okay, I just fixed that a little bit. I've got minus 8 degrees Celsius. I've got 0 degrees Celsius and 20 degrees Celsius. Now, in the beginning, we're starting at 20 degrees Celsius. And we are going to, over time, take energy away, and we're going to cool that water down to its freezing point, 0 degrees Celsius, okay? And then, over time, we're going to freeze that water. The liquid water is going to become ice, all solid. During this time, we're going from all liquid at 0 degrees Celsius to all solid at 0 degrees Celsius, okay? And then in the last part of this graph, we're going to take that ice, now that it's at 0 degrees Celsius, and we're going to cool it down to minus 8 degrees Celsius. There are 1, 2, 3 parts to this process, all right? So let's first establish that we are going to bring the temperature down from 20 degrees Celsius all the way to minus 8 degrees Celsius in this entire process, right? We're going from 20 to minus 8. So we're gonna start at a relatively warm temperature. Let's call it room temperature. And then we're gonna go to minus 8. Okay, so here we are with our LOL diagram. We're starting at room temperature. It's about 20 degrees Celsius. We'll stick to our rules. We'll say that we have 2 bars of energy, thermal energy. All right, we're liquid, so we're going to go with 2 bars of phase energy. Okay, of course, we're ignoring ETH. All right. And now we're taking energy away from the liquid water. We're freezing the water. We're going to end up, now, since this is a really cold temperature, I'm going to say we're at minus 8 degrees Celsius. I'm going to go with like a half a bar of energy. I just really want to emphasize it. That's very cold, so it's like a half a bar of energy. And we're at a solid, so the phase energy is just 1 block of energy. Okay, so we now lost 1.5 blocks of thermal energy, and we lost 1 block of phase energy. So when I'm drawing the energy that's left, that's our Q, we're going to lose, I'm going to draw this carefully so that that's a half a block right there. That's a half a block of energy, and this is 2 blocks of energy. That's 2.5 blocks of energy that are being taken away. And that is the LOL diagram that we would have for number 3 of this worksheet. Okay, please check the work that you did and fix, whatever you didn't do correctly. All right, it's really important that you get this right. And thank you. I'll leave you at that.